question consists of two parts. In part 1, you are given the equation of two lines, L1 and L2. Now P is a point on L1 and Q is a point on L2, such that PQ is perpendicular to both L1 and L2. Now just by looking at the requirement of this sum, I find that there are two ways of approaching these sums. But please don't be mistaken. There are more ways, but there are two ways which I'll be showing it to you. Now, since P is a point on L1, so let's write the position vector of P. So you will have OP will be equals to 1, 3, 2 plus lambda 0, 1, 4. Alright, for a specific lambda, alright, this P. Now, then what is OQ? OQ can be written as 2, 0, 3 plus mu 1, 1, 1. Okay? Now, they said that PQ is perpendicular to L1 and L2. Then let's find PQ, and if they are perpendicular, then we dot the direction of vector of L1 and the direction vector of L2. Both of them should be equals to 0. Then we can do something from there. Alright? Now let's find vector PQ. Vector PQ will be equals to OQ minus OP. Okay? So this minus this. So 2 minus 1, I get 1. So 0 minus 3, I got minus 3. This minus this, I got 1. Alright, so it's 1 minus 3, 1. Plus this minus this. So I will have mu. Here I will have mu minus lambda. And here will be mu minus 4 lambda. Okay? Now, so this equation can be rewritten as 1 plus mu minus 3 plus mu minus lambda 1 plus mu minus 4 lambda. Alright? Now, so this is vector PQ. Now, it is given that PQ is perpendicular to both L1 and L2. So, PQ dot the direction vector of L1 must be equals to 0 since it's perpendicular. So, this, now maybe I just write it here. So, 1 plus mu minus 3 plus mu minus lambda 1 plus mu minus 4 lambda dot 0, 1, 4 must be equals to 0. Okay? Now you dot it and then you simplify the equation. You should come to 5 mu minus 17 lambda equals to minus 1. Alright, I leave that to you. Okay? Now, the other one is I can use PQ dot L2. Alright? Must be, our direction vector of L2 must be equals to 0 since they are perpendicular. So, same thing here. I have 1 plus mu minus 3 plus mu minus lambda 1 plus mu minus 4 lambda dot 1 1 1 must be equals to 0. Alright, and what will I get from there? Now for this I will get 3 mu minus 5 lambda equals to 1. So this is equation 2. Okay. Now if you solve both the simultaneous equation, you will get mu is equals to 11 over 13 and lambda equals to 4 over 13. Okay. Now so you got both the values of mu and lambda. Now to find OP and OQ, you substitute this value of mu into OQ to find the coordinates of Q. Alright, you put lambda into OP to find the coordinates of P. For that, you will get P is equals to 1, 3, 4 over 13 and 3, 3 over 13. Alright, Q, you will get 2, 11, 13 and here you get 11, 13 and 3, 11, 13. Alright. Now we have finished finding the position or the coordinates of P and Q using one of the method. Now we shall go on to method 2. Method 2. Now it is given that PQ is perpendicular to both of these lines. Now if we cross the direction vector of line 1 and line 2, we will also get a vector that is perpendicular to both L1 and L2. Now since that vector is parallel to PQ, if it is also perpendicular to L1 and L2, then that will be equals to a scalar multiple of the cross product of the two direction vectors. Now let me show you. To get a vector that is perpendicular to both L1 and L2, we just take their direction vector and cross each other. So we got 0, 1, 4, that is this vector, direction vector of L1, cross direction vector of L2, 1, 1, 1. Now, what will we get from there? We got minus 3i, then you got plus 4j minus k. Okay, now this is the cross product of the two direction vector. Now since this is parallel to this, so we can write it over here. So I have 1 plus mu must be equals to minus 3s. Alright, let's say s is a scalar quantity. Alright, then minus 3 plus mu minus lambda will be equals to 4s. Alright, and this is 3 plus mu minus 4 lambda will be equals to minus s. Alright, since they are parallel, so one must be you need to multiply by scalar quantity. Alright, and it will equals to the other. Now so we can rearrange this. So we get from here, what do you get? We get 3s plus mu is equals to minus 1. All right, so how about the other one? You got 4s minus mu plus lambda equals to minus 3. And then you got minus s minus mu plus 4 lambda will be equals to 3. All right. Now you can key this into your GC under the system equation and you can solve for your mu and lambda. All right. Once you solve for mu and lambda, you can find mu and you can find lambda. All right. You can do that using keying it into your GDC. After that, you can substitute these two values. All right. The mu you can substitute into OQ and lambda you substitute into OP, and that you will get the coordinates of P and Q. All right, and you will get the same answer. We shall move on to part 2 of the question. In part 2 of the question, you are asked to find the equation of a plane which contains OP and is parallel to the line L2. Now P is a point that we have found in part 1 of the question. Now this is the given coordinates of P. Now we can first write down the vector equation of the plane. Now the vector equation of a plane can be given by R is equals to A plus mu B plus lambda C. Now A is a point that it passes through, and B and C are both vectors that are parallel to the plane. So we can put A as 0, 0, 0 plus mu. Now mu, what is B? B we can choose OP, alright? So mu OP plus lambda. Now this is another, the direction vector of L2 is another vector that is parallel to the plane. So lambda 1, 1, 1. Now what is OP? Now 0, 0, 0 we can leave it out, alright? So mu OP is given as 1, 43, 13 and 42 of 12 plus lambda 1, 1, 1. Now mu is just a scalar amount, alright? It's a what we can do is, no, this should be 13. I think this should be 13, sorry. Alright. Now mu is just a scalar quantity. Right? It is just a real number. Alright. So now so we can times 13, alright, throughout to this vector here. So it will be mu 13, 43 and 42. Now this is the vector equation of the plane, but this is not good enough because they want the Cartesian equation of the plane. Now, so we must learn how to convert this to the Cartesian form of the plane. One way is, let's change this to a scalar product form, alright? Now, the scalar product form is given by R dot N equals to D. Now, what is N? N is a normal that is a normal to the plane. That can be obtained by the cross, when we do a cross product of the two direction vector that the plane is parallel to. So we can use this, cross this, and we will get N value. So let's get N. Let's N be equals to 13, 43, 42, cross. All right, 1, 1, 1. Okay. And for that, what will you get? I plus 29J, this plus 30K. Okay. Now, so how to get D? All right, D, you can put any of this vector that is on the plane, because R represent a vector on the plane. All right, so you can use P dot n, and whatever value it will be D. All right, now we can use this. All right, R dot 1, 29, 30. Now, how do we get the value of D? Now we can use any point that is on the plane to dot this vector. All right, 1, 21, 30, the normal, and then that will be the value for D. Now, but since D crosses the point 0, all right, 0 is on the plane, so this value will be 0. Okay. Now, one way is you can use P to dot this and you get 0. The other way is you can 0, 0, 0, you dot this, also you will get 0. All right, but one special property is, now if the plane passes through the origin and you express this in a scalar, the plane in a scalar product form, then you will get your D will always be 0. So the Cartesian equation form will be given by x plus 29 y plus 30 z will be equals to 0. Okay, we have come to the end of the question. Thank you for watching and have a nice day.